So in our previous videos, we talked about Benjamin Libet's neuroscience experiment. Well, those experiments were done in the 80s, and so you might be wondering if there's any sort of more powerful experiments that have been done sort of since then. In this video, we're going to look at a couple of them that have been done. So we'll look at some fMRI experiments, we'll look at the methods and the measurements, then we'll look at some experiments using depth electrodes. Yet again, we'll look at the methods and measurements. Then we'll look at how scientists interpret these results. And then we'll look at how they might be used in an argument against free will. We're not going to spend as much time on this argument as we did with Libet's because the overarching themes are going to be pretty much the same. So some more recent neuroscience studies have performed similar experiments as Libet's that use more powerful equipment for measuring brain activity than the EEG machines that Libet used back in the 80s. So a 2008 experiment uses fMRI machines that measure sort of changes in blood flow in the brain to determine which parts of the brain are most active in a given time period. A 2011 experiment uses what are called depth electrodes that are placed actually on the surface of the brain itself and even sometimes a bit beneath the surface. Electrical recordings directly from the brain are more informative since the electricity measured by an EEG has to travel through the thick bone of the skull. You might be wondering, well, who do they do these experiments on? Usually it's done on people who are having sort of brain surgery due to epileptic seizures. Oftentimes they are awake while being operated on, but there's anesthetic so they can't feel, and they can elect to participate in a Libet-style experiment while this is happening. So let's talk about what I'll call the left-right button experiment. So in this 2008 experiment, subjects are asked to push one of two buttons, either the one that's on the left or one that's on the right. It's up to them when they're going to push it, and it's up to them which one they're going to push. So this is done while the scientists are using an fMRI to measure the subject's brain activity. And the scientists use a method that's similar but not identical to the clock method that Libet used to try to pinpoint when the subject becomes conscious or aware of their decision of what button to push. Now, they don't use the clock because they think that's maybe not as accurate. They think their sort of new method is slightly more accurate, but it still uses the same idea. Now, these researchers, when they ran the experiment, they measured brain activity that allowed them to make a prediction about which button, left or right, the subject was going to push up to 7 seconds prior to the subject's report of any awareness of a decision concerning which button to push. Now, this is interesting because, well, 7 seconds ahead of time means there's a lot of wiggle room. So even if the subjects are a little bit off on when they first felt the urge or first became aware of their decision to push the left button, that is 7 seconds in advance, they couldn't be off by that much. But the unconscious brain activity was only approximately 60% accurate in its predictions. In the next experiment, researchers performed a Libet-style experiment where subjects were asked to spontaneously click a key while watching a Libet clock. The subjects then reported where the hand was on the clock when they first felt the urge to press the key. So pretty much exactly like Libet's experiment. But this was done while electrodes were attached directly to the brain to measure electrical activity, those depth electrodes. Scientists were able to use measured brain activity to predict the time subjects would report feeling the urge with 80% accuracy. Now, Mealy gets a little bit more specific about this. So 80% of the time, significant changes in neural activity were detected approximately 700 milliseconds before the W time. So before they reported feeling the urge that the participant later reported. And the W time the scientists predicted using that sort of brain activity was within a few hundred milliseconds of the W time that the participant reported. So the W time there is just the time that they report feeling their urge to press the key. So how are these experiments supposed to pose a challenge to free will? Well, one way is the same way we've already discussed when we looked at Libet. This brain activity is measured prior to the person reporting being aware of having made any decision or feeling the urge to push a button. Thus, these researchers might believe that we have evidence that the subject's decision is made unconsciously in the brain, and the person only becomes conscious of that decision after it's already been made. Which leads to the following reason. We'll just call it the neuroscience argument against free will, and it's essentially the same argument we saw with Libet. The subjects in the fMRI and depth electrode experiments do not make a conscious decision to push the left or right button or when to push a key. So people probably never make conscious decisions to do things, but an action is free only if it flows from a conscious decision to do it. Therefore, probably persons or people lack free will. Now, the problems with this argument are still essentially the same ones we saw with Libet's argument. So the stronger equipment doesn't really change the dialectic too much. So consider the first premise. Well, why should we believe that the brain activity that the fMRI or the depth electrodes are measuring is in fact a decision that's being made in the brain? Yes, there is this unconscious brain activity, but why should we think that that unconscious brain activity is a decision? Remember, the fMRI, that brain activity only predicted with 60% accuracy which button they would push. So why should we think that the brain has already decided to push the left button or to push the right button? Similarly, we only had 80% accuracy in the other depth electrode experiment. Maybe what was being measured here is the brain preparing to make a decision. Or in the case of the fMRI, pushing the left button versus the right button, Mealy suggests maybe that brain activity just illustrates a certain bias that person's brain has. So it doesn't show that they've actually made a decision. It just shows that maybe they're leaning towards a decision, or that they're keeping track of roughly how many times they push left, how many times they push right, so that they don't fall into a pattern. And keeping track of that very roughly in their mind might bias them towards putting one over the other without actually making a decision. Regarding the second premise, even if these subjects are making an unconscious decision in these experiments, well, the decisions that they're making are still very different than the decisions we often make outside the laboratory. These subjects have no reason to push the left button or the right button. It's an arbitrary decision that doesn't matter. Similarly with pressing the key in the depth electrode, it's still the case that this is just an arbitrary decision. It doesn't matter if they push it after 20 seconds or after 40 seconds. There's nothing riding on that decision. And so there's no role for reasoning about the pros and cons to play in making that decision. That's very different than your decision to go to Tuskegee for university. That is an important decision, and it's not just utterly arbitrary. Regarding the third premise, it's still the case. Why should we believe that you need to be conscious of a decision at the time you make it in order for it to be free? If your earlier conscious, weighing of pros and cons still leads to or causes you to make an unconscious decision, who cares if you become conscious of it just slightly after you make it? All right, so that's it for this video. As you've seen, yes, there are some newer experiments that try to improve on Libet's methods, and they do in various ways, but it looks like the fundamental considerations regarding free will are the same. However, there is another way someone might use these neuroscience experiments to challenge the existence of free will, and it's a way that lines up with a philosophical challenge that's been around for over 2,000 years. It's what's known as determinism. The next video will briefly consider the relationship between determinism, free will, and these neuroscience experiments. See you then. Bye-bye.